Okay, now raise it higher if it was really, really cool. Yeah, that's what I like to see. See, most people during an eclipse can see the sky getting darker, like it's almost dusk, and you can even feel it getting a little cooler. Now, depending on cloud conditions and humidity, temperatures could drop a whole 10 degrees during an eclipse in mere minutes. But what exactly is an eclipse? Let's watch this short video, and then we'll explore it just a little bit more.
Solar eclipses occur when the moon gets between the Earth and the sun, allowing the moon's long shadow to intersect the Earth. This is the April 8, 2024 total solar eclipse. The central part of the shadow, called the umbra, sweeps across the surface at more than 1,500 miles an hour. It would move even faster if the Earth weren't also rotating in the same direction. The path of the umbra is known as the path of totality. People in that path see the moon completely block the sun, turning the day into night and revealing the sun's outer atmosphere, the corona. The umbra is over land for just an hour and 40 minutes before moving into the North Atlantic and then skipping off the edge of the Earth.
So, as that video mentioned, an eclipse happens when the moon passes between the sun and the Earth. So, you know how the moon and the sun look like they're the exact same size in the sky? Well, that's called having the same angular size, and it only happens because of a pretty neat coincidence. See, even though the sun is bigger than the moon, like 400 times wider, it is also 400 times farther away. So, from our viewpoint here on Earth, they look like they're the exact same size as the sky. Cool, right? Now this allows the moon to completely block the sun during a total solar eclipse, like the one we will see on April 8th. But during an eclipse, you will have the chance to see several different stages leading up to totality, which is when the sun will be completely blocked. But as that moon starts to pass in front of the sun, it doesn't cover the whole sun immediately. At first, the sun will have this crescent shape as the moon is making its way in front of it. This stage is known as partial eclipse. Now for most locations, partial eclipse will last around 70 to 80 minutes. And that moment, when the moon first touches the sun, that is known as first contact. As the eclipse continues, shadow bands will appear. Now these are long, dark, rapidly moving bands separated by white spaces. You can see them on the sides of buildings or on the ground just before and after totality. Though they can be faint and very difficult to photograph, so definitely keep your eye out. But they are caused by the light getting bounced around by the Earth's atmosphere. It looks almost like TV static. Now eventually, that crescent sun will break into a series of dazzling bright points along the moon's edge. Now these look like little bubbles of light rather than a perfectly smooth ring. These light rays are known as Baily's beads. They are caused by the sun streaming through the valleys on the moon's surface. Eventually, Baily's beads will start to disappear until only one singular bright spot is left. This looks like a diamond on top of a giant diamond ring formed by the sun's atmosphere. This means totality is almost here. And after just a few short minutes, we have finally reached totality. As that moon makes its second contact, you might catch a glimpse of the sun's chromosphere, which looks like a pinkish ring around the moon, or its corona, which looks like streams of white light like you can see here. Now these are both areas of the sun that normally we can't see. During totality, you should take a minute to observe the world around you. You might be able to see a 360-degree sunset. You might see some particularly bright stars or planets in the darkened sky. The air temperature will drop and often a silence will settle around you. It's also worth stealing a peek at the people around you, because often people have a very deep emotional response when the sun goes into totality. But what exactly are we learning from these eclipses? Well, NASA scientists are still studying them to make new discoveries about the Earth, the sun, and our space environment. Total solar eclipses are particularly important because they let us see a part of the sun's atmosphere called the corona that is too faint to see unless the bright light of the sun is blocked, like during an eclipse. Now scientists can use these instruments